All right, so today we're going to learn how to find when f of x equals g of x. It's kind of like the systems that we've been talking about. That's why we're going to do this following that lesson. So let me just zoom in on this so we can see it a little bit better. All right, so we want to find when f of x equals g of x. We're going to do it both algebraically and graphically. If you are asked to do it algebraically, that's probably going to be a short answer question. Whereas if you are asked to do it graphically, or it just doesn't say algebraically, then it's probably going to be probably going to be multiple choice. So this is how you would do so algebraically. You would set the equations equal to each other. Then you would solve. And now what's different about f of x equals g of x than the systems that we were solving before is that only the x value, only x values are your answers. If it says system, solve the system, then you need x and y. But if it says find when f of x equals g of x, then it's only the x. To do this graphically, you would type both equations into y equals. So one's going to go into y1, the other's going to go into y2. Then you would press second, trace, and then option number 5 says intersect. Then you're going to, it's going to bring, after you press 5 or after you press enter, whatever it is that you're going to press, it's going to come up as a cursor on the graph. So you are going to hover over the point where it's meeting, and then you're going to press enter 3 times. So you have 3 enters. Once it's over the point, you are not going to move it anywhere. It's just going to stay on top of that point. And then same thing. It's going to give you both x and y when you do this, but we only care about the x values. Only x values. Okay, so let's look at 2 examples. The first one says, algebraically determine when f of x equals g of x, when f of x is that and g of x is that, rounded to the nearest hundredth. So because this says algebraically, we have to do this by hand. If we wanted to check it in the calculator, we could. So our steps to do this algebraically, you're going to substitute f of x into f of x and g of x into g of x. So we have x squared minus 9x plus 12 equals 5x plus 2. So this is a quadratic equation. So I'm going to set it equal to 0 and see what I'm looking at. So I have x squared minus 14x and then plus 10 equals 0. So this is not factorable. There's no 2 numbers that multiply to be 10 but add to be negative 14. So I'm left with either completing the square or quadratic formula. This looks like an easy one for completing the square, so that's what I'm going to do. I have x squared minus 14x. I'm going to bring the 10 to the other side. I subtract the 10 over. So I have a blank here and a blank here. Half it. Square it gives me 49. Share it to the other side. And then negative 10 plus 49 is 39. So now I take the square root of both sides. So x minus 7 equals plus and minus the square root of 39. And then I would add the 7 over. 7 plus and minus the square root of 39. Now, if this said in simplest radical form, then you would be done. However, this says rounded to the nearest hundredth, so I have to get actual decimal points. So one of my answers is going to come from 7 plus the square root of 39, and the other one's going to come from 7 minus the square root of 39. So I type each one into the calculator. This one is going to give me 13.24 rounded to the nearest hundredth, and the other one will give me 0.76. rounded to the nearest hundredth. Okay, now again, only your x values matter, so you do not have to then go in and plug this into the equations to find the y. These are your two answers. You are done. So now if we look at number 2, number 2 says if f of x is 5 divided by x minus 1 and g of x is that quadratic, determine all values of x that satisfy the equation rounded to the nearest thousand. So notice number 2 is missing the word algebraically. So you are meant to really just do this in the calculator. So what you can do for work, you would write 5 divided by x minus 1 equals, that's f of x, equals g of x is x squared plus 3x minus 4. And then if you want to, because technically this is a short answer question, so you really should show some type of work, you can draw the sketch of the graph. So I go to my calculator. Oops. I go to my calculator, I go to y equals. I type 5 over x minus 1 into y1, okay? If you're going to not use that alpha y equals number 1 button, then you're going to do 5 divided by x minus 1 in parentheses, and then y2, and then I look at my graph. So the first function, that 5 divided by x minus 1, that's the one in blue, and then the red one is the quadratic. So on my paper, I'm just going to draw a quick little sketch of what I'm looking at. And I have this one comes down like this way, and then up here also. And then my parabola looks something like that. So I have 1, 2, 3 times where they meet. My directions say determine all values of x that satisfy the equation. So I'm going to get 3 x values. And I'm going to round them all to the nearest hundredth. So I'm going to pick up my calculator now. I'm going to press second, trace. Option number 5 is intersect. And then I'm going to hover over the point. Hover over the point. Once I'm there, I'm like right on top of it. I'm going to press enter 3 times. It says first curve, enter. Second curve, enter. Guess, enter. And then that's your intersection point. But remember, we only want the x values because it's asking for when f of x equals g of x. So on my paper, I'm going to write that x value, rounded to the nearest thousandth, was negative 3.781. Now I'm going to do it again because I'm looking for all 3 of my values. So I press second, trace again, press number 5. Now I'm going to hover over the next point. Again, I want to get right on top of it. Then I press enter 3 times. And that intersection point is negative 0.138. Again, only the x values. And then I'm going to do it for the last time. Second, trace number 5. I'm going to move my cursor. It's a little weird. This is the rational function. It's going to go down and then come back up, you'll see, as you keep pressing the right arrow key. There we go. I get as close to my point as I can, press enter 3 times, and it gives me the last one, 1.919. And that's how you would do that graphically. Okay, again, to show your work for this type of question, you can just draw a graph. You can write the equations equal to each other, but you really shouldn't do this with just your answer. Again, this would be a multiple choice question if it didn't say to do it algebraically, most likely. Okay, we're going to practice in class when I see you guys next. Have a great day.